In this video, we'll derive some formulas for the derivatives of f of x equals c, where c is a constant, and f of x equals x. So let's begin with the derivative of a constant function, f of x equals c. So by constant, we just mean that this number c is some fixed number. So it's not a variable, like something that it can change. It might be something like f of x equals 5 or f of x equals negative 12.1. So I think this is easiest to show with a picture. If we think about the derivative as being the slope of the tangent line and drawing a tangent line. So I'm going to draw some axes. And the graph of f of x equals c, if I label c as some point, some number on the y-axis, f of x equals c, this is like y equals c. That's a horizontal line. I have to draw a horizontal line that goes through c on the y-axis. Okay, and what I'm going to do is I'm going to label some x coordinate. I'm going to call this x. I'm going to draw the dot. I'm going to draw that point on the curve here. So the derivative represents the slope of the tangent line. And at that point, that tangent line, if I were to draw it, is going to be perfectly flat. It's just going to lie exactly on that line. So at that point, the slope of the tangent line at this point is 0. Therefore, the derivative of this function, f prime of x, is just going to be 0. Okay, and that's going to be true no matter what x value I take, even if I were to take an x value over here, say, and draw the tangent line at that point, it's still going to have a slope of 0. All right, so that's the derivative of a constant function. It's just 0. All right, so next, let me talk about some notation. So when we write dx, this looks like a fraction, but it's not actually a fraction, it's just notation. I say dx. This is a differential operator. It's a differential operator. Differential means having to do with the derivative. An operator means it's going to perform some action. And what it means is take the derivative with respect to x of ... and whatever I write after the ddx. Okay. So when we say with respect to, in this case with respect to x, that means the x is the variable. This is the variable in the function. And we're asking, when we change the x coordinate by a teeny tiny amount, how is the value of my function, the output of my function, that instantaneous rate of change, what is that? Later in our course, we'll sometimes be dealing with equations that have more than one variable floating around on both sides. And in those situations, we'll need to be specific about what variable we're taking the derivative with respect to. Okay, so if I practice using this notation, I would say ddx of a constant of c is equal to 0. So we now have a formula for the derivative of a constant function. Next, let's get a formula for the derivative of f of x equals x. I'm going to take the same approach here. I'm going to do it with a picture. Because both the constant function and f of x equals x have a very simple graph, for which I can always draw the tangent line easily. So if I draw some axes, and I draw the function f of x equals x, that's a line with a slope of 1, and the y-intercept is 0. Y equals x, or f of x equals x, it looks like this. All right, and if I take a point on the graph, let's label this x coordinate as x, and I draw that point there. The y coordinate at that point would also be x. But if I draw the tangent line at that point, that tangent line would just lie perfectly along this line. So if I measure the slope of the tangent line at any point is going to be 1. That's the slope of this line. Okay, so because of that, f prime of x is equal to 1. And if I practice using this ddx notation, we would get ddx of x, the derivative of the function x, treating x as the variable, is 1. In terms of our goals, we finished our first goal, which was to get a formula for the derivative of a constant function and the function f of x equals x. So notice that now when we have to take the derivative of functions like this, we don't need to use the definition of a derivative involving limits. We'll be able to just use our formulas. So over the course of the next several videos, we're going to continue to develop more shortcuts like this.